exponential equation. So the pre-requirement for this video would be the exponential and logarithmic functions. Let's start with some examples. Here we have 3 to the power 2x plus 3, equals 3 equals 12. So here it's not the usual equations we deal with, it's exponential. So on two sides we have, on each side of the equal sign we have an exponent. Here the exponent is a binomial and here it's a constant. So as you can see here, both of them have got the same base. So if bases are the same, that means exponent must be the same in order for the two sides of the equal sign to be the same. Okay, so exponents should be equal to one another. In order to solve this equation, then we equate the exponents. So 2x plus 3 should be equal to 12. That's a linear equation. So here I subtract -3 from both sides. 2x equals 9. I divide both sides by 2. X would be 9 over 2. Okay, so that means in the original equation, if I substitute x as 9 over 2, the two sides would be exactly the same. So let's check the answer. Okay, so here I have 3. 2 times 9 over 2 plus 3. And we want to make sure it's equal to 3 to the power 12. Okay, so 2 times 9 over 2, it's 9 plus 3, it's 12. So that means that's the correct answer. Let's do another example. So here I have 5. Exponent is 6x plus 1. On the other side of the equal sign, I have 125 and the exponent is 3. So in this example, the two bases are not the same. The exponents are not the same either. So in order to solve an exponential equation, either the bases should be the same or the exponent. Let's look a little bit more closely. Can I make the exponent the same? No. But how about the bases? Yes. So 125 can be converted to 5 to the power 3. Okay? So here, in the next step, I will convert 125 to 5 to the power 3, and I substitute it, and then I simplify. Then I would get both bases would be the same. And then if I want the two sides of the equal sign to be exactly the same, then the two exponents must be the same. So that means 6x plus 1 should be equal to 9. In order to solve this linear equation, we have to isolate the x. So I add -1 to both sides, so 6x equals 8. And then I add both sides by 6 to get the final answer. Therefore, the final answer would be 8 over 6, which you can also simplify and make it 4 over 3. Okay, let's continue with another example. In this example, again, on one side of the equation, we have 25 as the base, and on the other side is 125. So the bases are not the same. If you look closely again, here the exponent is 2x, and on this side it's 3x plus 1. So neither the bases nor the exponents are not the same. So what can we do here? Remember, we can always convert the bases and have a common base. So here, 25, I can convert it to 5 to the power 2. And for 125, I convert it to 5 to the power 3. And then after simplification, I would have 5 to the power, so let me move this one a little bit. Okay, so now it should be you should be able to see. So here I have 5. Okay, so here neither the bases nor the exponents are not the same, but remember I can always convert the bases. So here 25 can be converted to 5 to the power 2, and then 125 can be converted to 5 to the power 3. Okay, and if I do so, then I would have all the bases the same. So here this would change to 5 to the power 4x on one side, and on the other side I would have 3 times 3x, which is 9x, and 3 times 1 is 3. So on this side I would have the two bases the same, both of them are 5, and in order for these the two sides of the equal sign to be exactly the same, the exponent must be equal. So that means 4x should be equal to 9x plus 3. Okay, now this is a simple linear equation, and let's solve it together. So I add negative 9x to both sides. Okay, so it turns into negative 5x equals 3. Now I'll divide both sides by negative 5 to isolate the x. So the answer would be negative 3 over 5. So that means if you substitute x as negative 3 over 5 in this exponential equation, both sides would be exactly the same. Now let's move on to another interesting example. So in each video I try to start from simple examples into more advanced ones. So as you can see, the first one was really simple, the second one and the third one a little bit more different, not that easy. But the fourth one, it's really interesting. So here we have 1, 2, 3 different bases, and then as you can see, two of them are 2, one of them is 32. Again, neither the bases nor the exponents are not the same, so we convert the bases. So 32, I will change it to 2 to the power 5, substitute, and then try to simplify. So first of all, try to get the same base or the same exponent. If the bases are the same, that means the exponent must be the same. That is the case in here. Okay, so I will change all the bases to a common base, and then this will make my equation much simpler. So after that, you should be simplifying. Okay, after simplification, your exponential equation would be reduced to a linear equation, and then you can solve it. Well, it actually could be linear or quadratic or even high order, but for this video we will focus only on linear equation. So here, after substituting the 32 with 2 to the power 5, I would have and after simplification, on one side I would have 2 to the power x plus 15, okay, and on the other side I would have 2 to the power 4x plus 1. And as you can see, the two bases are exactly the same, so that means the two bases are exactly the same, so that means the two exponents must be the same. So let's move on. Here I have to equate the two exponents, so x plus 15 should be equal to 4x plus 1. So I start by isolating the x. For isolating the x, I add negative 4x to both sides. It will turn into negative 3x plus 15 equals to 1. Now I want to isolate the x, so I add negative 15 to both sides. Then it would turn into negative 3 times x equals negative 14. To isolate the x completely, I have to divide both sides by negative 3, so the answer would be negative 14 over negative 3, which would be in its simplest form would be 14 divided by 3. So here is another example. Again, on one side the base is 3, on the other side the base is 243, which is not a favorable thing. And then as you can see here, the exponent, it's 1 minus 2x, but here there is no exponent. When the exponent is missing, that means it is 1. Okay, but if you look closely, again, we can convert 243 to 3 to the power 5. Okay, so 243 is 3 to the power 5, and remember, all of these will be, you can get, all these answers like clearly and so fast by, doing so many examples. Like practice always makes perfect. So now I just substitute 3. This side of the equation is not changed, but on this side, instead of 243, I substituted 3 to the power 5. So now the two bases are the same. The exponent must be the same. 1 minus 2x is equal to 5. So in order to solve this linear equation, I add plus 2x to both sides, and it will change into 1 equals 5 plus 2x. And then I will simplify it one more step. I add negative 5 to both sides, and then the answer would be negative 4 equals to 2x. So the x would be negative 4 divided by 2, which is negative 2. Let's move on to example 6. So here on one side of the equation, I have 4 to the power something, and then on this side I have 1. And as you can see, none of the bases are not the same, the exponents are not the same. And for me, what I know from the rules, that 1 can be written as 4 to the power 0. Okay, so if you remember from the rules, any number raised to the power 0 would be 1. That's what I do. And why I chose 4, the reason I chose 4 was that I want the bases to be exactly the same. That's why I chose 4. And then here, then it turns into 4 to the power 3x minus 2 equals 4 to the power 0. So that means the exponent must be the same. 3x minus 2 should be equal to 0. Then I add plus 2 to both sides. Then it solve this linear equation. Then it reduces to 3x equal 2. Then I divide both sides by 3. Then I get my final answer. For the next example, I have 4 to the power 2p equals, on this side I have two different expressions multiplied by one another. So what I know is that what I can see from here, the bases are not the same, but they are convertible to one another. So instead of 4, I can substitute it with 2 to the power 2, and for square root of 2, I can put 2 to the power 1 over 2, or 0.5. So next step would be simply substituting, getting all the bases the same, and then simplifying. From here, the bases are the same. So again, if the bases are the same, the exponent must be the same. So 4p equals p plus 7.5. And then to solve this linear equation, I should isolate the p here. The variable, the unknown variable is p. It doesn't matter. It can be x, y, p, or any other letter. So here, the final value for p would be 7.5 divided by 3, which is 2.5. Now let's do another example. 2 to the power x multiplied by fraction equals 32. Okay, so again, the same scenario, none of the bases are not the same. And even this one is a fraction, which is the big number is in the denominator. What I know, 32 is 2 to the power 5. So at least I can have all the bases the same. So I just substitute 32 with 2 to the power 5. In the next step, I try to simplify. So 2 to the power x doesn't change. 1 over 2 to the power 5, remember, it can flip with the negative power added to, with the negative exponent. And here, it doesn't change. So let's simplify this side. This side, the bases are the same. So the exponents would be added. 2 to the power x minus 5 equals 2 to the power 5. Bases are the same? Exactly. Exponent must be the same. So x minus 5 should be equal to 5, which means x is equal to 10. Okay, this is example 9. So here I have 81 multiplied by 9 to the power negative 2x equals 27. So here I have 3 different bases, and none of the exponent is the same, like the exponents are not even equal to one another. So what I know from before, I can convert all of these to a common base, and which happens to be 3. So 81 is 3 to the power 4, 9, 3 to the power 2, and 27 is 3 to the power 3. Nice and neat. So what I'll do, next step, I will simply substitute. So 3 to the power 4, 81 substituted with 3 to the power 4. Instead of 9, only the 9. I substituted with 3 to the power 2, so negative 2x stay. And then instead of 27, I substituted with 3 to the power 3. Okay, so now in the next step, I have to simplify. So 2 times negative 2x, negative 4x. Okay, here the bases are the same. So that means the exponents must be the same. Okay, so what I can do, I will first simplify 4 minus 4x, the base is 3, and on this side is 3 to the power 3. So the exponent 4 minus 4x is equal to 3. So that's a linear equation, which in order to find the answer, you have to isolate the x, and then your final answer would be x equals 1 over 4. Next example would be 9, exponent is negative 3x, multiplied by 9, exponent is x, and this side is 27. Okay, so here on this side, the two bases are the same, but it's different from this side, so it doesn't work. So what should we do? Again, change all the exponents to something common. So 9 and 27 can be changed, converted into 3 to the power something. So 9 is 3 to the power 2, 27 is 3 to the power 3. Okay, so what I'll do next, I just simply substitute the bases. So here, instead of 9, I put 3 to the power 2. Instead of this 9, I put 3 to the power 2. Instead of 27, I put 3 to the power 3. Okay? Then simplify. This is 2 times negative 3x, negative 6x, 2 times x, and this doesn't change. So in the next step, I will just simplify this side, which is negative 6 plus 2x, which is negative 4x. And on this side, the exponent is 3. Because the bases are the same, the exponent must be the same. So negative 4x equals 3, and x is negative 3 divided by 4. Okay. So this is the last example for this video. Again, on this video, the two bases on one side are 6, but on this side it's a fraction. But I know that 216 is 6 to the power 3. So what I'll do in the next step, I simply substitute. So I substitute here on this side, negative 2x plus negative x would be negative 3x. And instead of 216, I put 6 to the power 3. So 6 to the power negative 3x on this side should be equal to, instead of 1 over 6 to the power 3, remember, I can flip and I change the sign. So 6 to the power negative 3. And from here, the two bases are the same. That means, yes, the two exponents must be the same. So negative 3x is equal to negative 3, and x is negative 3 over negative 3, which is plus 1. I hope you enjoyed this video. Please don't forget to subscribe to my channel. See you next time.